But what we couldn't get was athletics to say, let's do it. You know, it wasn't our building, so to get us an auxiliary building, so we had to have their buy-in to do this. They all loved the project, but they couldn't make a decision.
Yeah.
So
this is what, 2 years in the making?
2 years, yeah.
Yeah. So now to move over to Rocky Mountain Power, they have a program called, well, they used to call it Self-Direct, where somebody like us who had high energy bills, there's a part of the bill called the Customer Efficiency Services. It's a 2 or 3% add-on. You probably all have it in your houses if you're fed by Rocky Mountain Power. Everybody pays it. But basically, you can opt to get a credit on that charge as an incentive, and they'll pay up to 80% of a project cost that way. Which, you know, if your bill's only $65 a month, it's not enough. But when we're paying millions, it adds up. So we like to get that self-direct credit. So we had bundled this project with some other things 2 years ago into a self-direct application with Rocky Mountain Power to do the project. Have it all set up. We're just waiting for athletics. Well, finally got to the point where we had to take this project out of the package and do the rest of it and get those projects done and get the incentive. So that all happened months ago. In the meantime, Rocky Mountain Power changed their incentive program, so self-direct went away. And so now they have what they call Watt Smart Business. And as part of Watt Smart Business, you can choose at the end of a project to say, I'll either take bill credit or get a check. You get a check, it's going to be a prescriptive incentive, $100 a fixture.
Yeah.
We might have got like an $8,000 incentive on this.
It's like $12,000.
$12,000 for this project with a check, or $200,000 in bill credit. You know.
Which would you pick?
Yeah. Well, and that's the only way we can make this work, because see, we're not paying the bills. I mean, so if we had all set up to where we get the bill credit, that pays back 80% of our project cost to do this project, and then we create an MOU, a memorandum of understanding with athletics, to where they will pay an additional, $2,000 a year or whatever it is, more than that. It's like probably $15,000 a year on their bills to pass along the energy savings to us. So we can recoup our money, they get their lighting, we're all happy. So anyway, we finally get it all straightened out with athletics. We're going to do the project. We launch into it, review it, submit it, and then they say, well, this doesn't pass our program requirements,
Rocky Mountain says that?
Rocky Mountain Power says, wait a second, because it has a long payback. I mean, to be fair, I think it's up to an 8-year payback on to get bill credit.
And we were at 11.
We're at 11.5 years. However, in the past, we've done projects before where we pushed the envelope and they were always approved. And the nice thing about self-direct was that you'd have a letter in advance. You submit it to that self-direct, they say this passes. If everything works out, you'll get the credit. Well, bill credit, it's an end of project deal. So we spent the money, we don't know, so we submit it, Bill submits it, everything's fine. Oh, this doesn't pass. So
it was a real hard discussion with Jeff that morning when I got the email, because that would have eaten up a majority of our working budget.
Yeah, we would have been out. We would have been out about $200,000 gone on this project. And so we were sweating bullets there for a while, wondering how this is going to work out. And so Rocky Mountain Power has what they call a secondary
review process.
Yeah, review. So they'll send projects to a third-party consultant to review to measure the effectiveness of the project to see if it passes some kind of secondary requirement to allow the credit. And just today, we got a letter, or yesterday maybe. Well, Bill was out on vacation anyway. We got a letter from Rainey saying, telling us that it passed. But when I opened up the email to read it, I just had to laugh because it was like really business-like, and she didn't even get to the point where we said that we got it until like 2 or 3 sentences into the email. I would have expected she would have said, "Congratulations, you get the money."
We've been holding our breath for 3 months.
Yeah. So anyway, it passed. We get the money. We're in business. We're happy, but.
How old is that building? It's not very old, is it?
No, and it's, it started out as an inflatable. It was like it was
Right.
open and they built like a big tent, like a tennis covering over it.
Yeah.
And then I think it was when, close before Kyle Whittingham, Urban Meyer, when he came, he said that was one of the stipulations for him to stay was to have a covered practice arena.
Oh,
So it
okay.
goes back to the last couple of years of his tenure.
Oh, okay, so it is.
So it's
Wow.
5 or 6.
So it would have been 10,
Yeah.
10, 12 years
Well,
old.
it's not,
Oh, okay.
not that old, really.
So it's not, there's another building that they just built.
Well, they just did the
Newer,
football
right?
training center
Okay,
down
so
there. That just opened last year. They redid that. This building is to the south. and
Yeah, I
that's
think-
right there.
My son had a practice there or something.
Yeah.
They rent the
Are,
field.
are they gonna change anything to make sure that stuff like that doesn't happen anymore?
No, there's no changing Rocky Mountain Power. We just have to learn how to deal with the program. I mean, there was a situation where we had it approved under self-direct, and it was really our fault as a university that we had to pull it out of it. And the changes in the incentive program happened, and but that's just the kind of stuff that we get to deal with here, and trying to figure out how to fund, and we have to try to get a little creative financing to try to figure out how to make projects work and all that kind of thing. But anyway.
Is there anything that you or politicians or anybody can do to influence Rocky Mountain Power and how they decide to?
Yeah, I mean, the Public Service Commission is who regulates these programs, these tariffs, they call them. As ratepayers, I mean, we can definitely appeal to Rocky Mountain Power or somehow make our voice heard and that kind of thing. We haven't really gotten very politically involved in the process in the past, but
But even in Rocky Mountain Power's defense, in the last year or so, when they were looking at revising the program, they talked to us and asked questions how we can make the project, how the program can be made better. But one of the things that happened the way the program was structured before was they had an outside engineering firm that was actually managing the program for them. So they hired Nexon Engineering. And so those engineers were the ones that I dealt with all the way through the process. So if something looked a little iffy on the ROI or, that we were, had to be careful, we got guidance all the way through the project that, so that let's watch our budgets, whatever we needed to do to make it work. When they changed the program, they brought all that in-house. And so they have a staff that really hasn't managed the program that directly before. And I don't think they probably really realized kind of what we were expecting or the type of relationship we had with Nexon before. And my fault was that I made some assumptions based upon how I had worked with Nexon that no red flags came up, so everything was cool. And they didn't, so it was really, some miscommunication that happened as well. But so, like Jeff said, we just have to be a little more careful as we use the program now and make sure that, the onus is on us now to make sure that, that our ducks are in a row.
So is Nexon only doing residential now?
I'm not sure what all their contracts are with Rocky Mountain Power. I know they're still involved in a lot of different things, but
I think they're doing some new construction stuff.
I know they still get involved in some of the new project reviews and things.
Yeah.
So anyway, I guess we can.
Yeah, I don't have a phone number to send an email.
Okay.
Oh yeah, it's a holiday weekend as far as any year.
Yeah, I'm surprised I'm here.
You?
Yeah, Bill's been on
I'm in
vacation.
vacation.
Bill actually came back from vacation.
That's nice.
It's the first time I shaved all week.
So today's just going to kind of be a variety show. We'll talk about a few different things, kind of give you an idea of what we deal with, and then go look at some things. our pattern in the past has been to go down to the main plant, which is just down the hill here, and look at the cogen unit, which essentially, unless it's off, we can open the doors. It's just a big box.
It is off, I think.
Is it?
Because they're still, I don't think they've got the gas line connected up yet,
Oh, okay.
unless it happens this
We
week.
can open the cabinet and look at the jet engine in there. So we'll go down to the plant, and then we'll go up to the North Chiller plant, which is a chiller plant that we make, of course, chilled water and store it in the 3 million gallon tank. And so it can produce chilled water at night or on off-peak hours, and then feed the chilled water to the buildings in the loop during the day. So we'll go take a look at that. I think to start though, I thought I'd just bring up a couple of things that we're working on. Kind of got a little bit of a taste for lighting project and those kind of things with the story we just told. One of the, let's see, I'll bring up something you'll be learning about if you don't know about already. Is Energy Star. That's, yeah, so, I'm sure you guys are familiar with Energy Star, portfolio manager. Anyway, it's something that you'll definitely use. I don't know if you guys if you still do the thing in this class where they use Energy Star login.
We do portfolio manager related classes.
Yeah. So this is just taking a look at our energy consumption for the university. But one of the interesting things about Energy Star is that it doesn't really work for most of our buildings. They don't really have classifications, because what you do is you take all of your utility bills, electric, gas, and upload all that data into this program. This is the Department of Energy, or not Department of Energy, EPA program, and it'll kind of trend data for you, offer various comparisons and different things. And the biggest reason why you want to do it is to get a score. Of course, it says right here, not eligible for Energy Star certification. And if I click on that, it says that we can't do it because we're a campus of multiple buildings and you have to be one of these types to get a score. But it does show right here for our campus what our current EUI is, and it says right here what that is. EUI is energy utilization index, or sometimes people call it energy use intensity. But it's kBTUs per square foot per year. So right now our current EUI is 326.8. That's campus wide. And our baseline, which was back here, I think right there in 2008, was 350.5. So we are trending downward in our energy usage, getting a little bit better.
And growing at the same time.
And growing at the same time. Of course, this is per square foot, so it can be a little skewed that way. I mean, our actual overall usage is up, but per square foot is down. But that's just kind of a quick snapshot of where we're at, trying to save energy. And fortunately, this is going down, not up. A little graph right there kind of showing year over year how it's looked. But yeah, you'll get a little bit of experience with this. We have 222 buildings that are part of our campus in this program, and this is looking at it as a whole. We don't have individual buildings in here. The biggest reason why is our metering systems isn't that great. The campus is actually fed by Rocky Mountain Power at 3 locations. We have 3 substations, one down by the stadium, one by the hospital, and one over by Red Butte Gardens. And those are the 3 points where we're fed by Rocky Mountain Power, and from there we own all the equipment, or we're going to own all the equipment at the substations currently lease a couple of them, and then from there we own all of the infrastructure that feeds this. It's like a city, and we own, you know, all the cabling, all the everything in the ground, transformers, the whole bit. And we have a lot of meters, and it's getting better, but a lot of buildings don't have meters. Just wasn't important, historically speaking. But it's getting more important. That's a big thing we do. In terms of natural gas, about 85% of our natural gas goes to two plants. The one that we'll go look at down here, which produces some electricity and also high temp water. And high temp water is, it's about 360 degree water under high pressure, so it doesn't turn into steam. And that's what's fed through the campus as district energy to heat all of our buildings and all that kind of thing. So we use hot water instead of boilers in each building. There's one up in the health sciences area that feeds that campus, and then this one here, which feeds most of this campus. So 85% of our natural gas usage goes into making high temp water. So that's why we kind of have to look at things at this campus level, not so much at the building level. So, and then, so that's a fun little thing. And the other thing I thought I'd show you guys is right now, one of the programs that we're working on is we are part of the Better Buildings Challenge, which is a Department of Energy program. And this is more than anything right now. There's a couple of factors that are driving the need to reduce energy here. I mean, of course, reducing cost is huge. I mean, our overall utility budget for natural gas and electricity is right at about $25 million per year. And so when you have that big of a number, there's a lot of interest in trying to reduce that, try to curb the increases. And then on top of just needing to save money, we also committed to this program a couple of years ago. And this is interesting because a lot of times institutions like this might make commitments to different things and say, yeah, we're gonna save this and reduce that, and it feels good and looks good, but nobody really cares. You didn't catch that on there.
You got it all.
Yes. I mean, people care, but I mean, it's just high level. The administration can sign on to things and not really ever expect to or really intend to reach those goals. But this one has received a lot of high level support, and so our commitment is to save 20% energy. Again, measured by energy intensity by 2020. As you can see right here, we're at about 8% down from our baseline year right now. So yeah, we're making progress, and a lot of that has come from just good operations. We haven't really done a lot of big projects specifically to meet this goal, but we are doing a lot of things that are right. Since it's measured on energy intensity, or normalized per square foot, when we build new buildings, and we're typically building LEED silver or better. There you get off from LEED. And in our design standards, we're required not only LEED, but we have very specific requirements in the energy area. So our buildings are required to be 40% better than code in terms of energy usage. We don't always hit it, but that's the goal. So our new buildings have really helped in this way to reduce that energy intensity. And then there's just a lot of operational things we're doing. I mean, energy management, you're seeing 2/3 of energy management here at the U. We don't have a big group, but it's not all on our shoulders to do everything. I mean, we have construction project managers, we have campus utility services, the people who manage the systems here, and a lot of those people are getting, they're starting to focus more on energy and efficiency and those kind of things, and it's really helping to move things in the right direction.
And then we really have and like Justin, we got a higher level of commitment. So when you have university presidents and vice presidents and whatnot that are for the program, then it tends to get a little bit more notice. So
Exactly. So anyway, like I was saying, this is a Department of Energy program. It's a kind of sub-program of what they call the Better Buildings Alliance, which we are also members of the Better Buildings Alliance. The whole idea is to invite partners to be part of this, to be examples to the rest of the country. This is how you can do it, and one of the things that we do is we share information. So anybody can come on this website and they can see like one of our showcase projects that we did, which is a building over here in Research Park called the Dumkey Health Professions Education Building, which we did a controls upgrade and boiler upgrade project in, and as a result we're seeing 41% reduction in energy in that building, saving about almost $60,000 per year. So it's a really good project, and so we've shared it here on their website so other people can come in here and look at it and see what we did. Save energy. A lot of the stuff we're doing is not ultra cutting edge, innovative stuff. We're just doing good operational things and seeing a lot of great results from it. So something we're pretty proud of. One thing that you'll definitely get a feeling for as you go through the program is how important payback is. This was interesting because the project cost was about $1.25 million, and we're only saving $57,000 per year. So who wants to do quick math to figure out what the simple payback is on that? 20 some odd years. So by the book, that's not good. But there were things that helped us to do this in spite of. In fact, this project wasn't done strictly for energy savings. It was done because the building had some extreme operational needs, and the energy efficiency was kind of the icing on the cake, which I think is a really good story, because the fact of the matter is to run things well. If you have a building and you want it to run well, and you want energy savings, it's not like they are counter to each other. They go hand in hand. If you run a building good, and good by good I mean comfortable environment that's meeting the needs of the building, and satisfying the mission of the building, and good occupant comfort, all those kind of things. If you do that efficiently or effectively, you can see tremendous energy savings at the same time. I think that's probably the best story that comes out of this project is it was not done to save energy, but we saved a lot of energy just by doing things right.
And these numbers contribute to that association you said you guys were part of, where it was showing 8% towards your goal.
Yeah.
Is that, what percent do you think this one project would be of that 8%?
Contributing to that 8%?
Yeah, exactly.
Dropping the bucket, really.
Yeah.
So in a building like this where our annual energy consumption is, let's look at what our energy consumption is for this building.
I'm just curious how they correlate.
Yeah, I mean, this is helping to go in the right direction, but it's not, it's not like we did this and hey, we're making this tremendous.
Yeah, exactly.
Yeah.
So how many square feet do you have altogether?
Yeah, so the total campus square footage is right around 15 million square feet, and that's including what we call lower campus down here, the health sciences campus, which is up here where the hospital and everything is, and also housing, which is Fort Douglas, and properties in Research Park. Right around 15 million. I forgot exactly what the number is, but the amount of that space that is educational, the stuff that we're involved in, it's about half that, probably about 7 million square feet. that we impact directly with the work that we do. It's kind of interesting because facilities here, the mission of facilities is to support the state-funded space here on campus. And so that's why we don't really, like athletics and the hospital, that's separate, because the state does not fund those operations at all. The tax dollars don't fund those operations. They're self-supporting. And so, and that's why as state-funded people, as state employees, we focus on the state-owned property. However, we also interface a lot with the auxiliaries, working with athletics and housing and the hospitals and those different places to try to help them and be a resource to them because they don't have energy people. Maybe one day they will. I would hope that the hospital in particular one day will have their own energy management group because the hospital, I mean, they've got 5 or 6 hospital buildings and then another small handful of more research buildings that they're involved in, and those are all at the highest level of usage, energy intensity. I think restaurants are kind of by the book, kind of the highest on average, but healthcare is right up there.
So they don't have anybody as energy.
They don't have any dedicated energy management people. They have their own facilities and engineering group where they handle all the facilities, manage them.
Yeah.
They have their own shop people, electricians, plumbers, control technicians, but no energy management specific people. So anyway, so yeah, it's a lot of square footage that we deal with. What time is it? 6:15. I want to make sure we have plenty of time to go walk. And I think now might be a good time to go ahead and go. I guess I'll spend a second just kind of showing you some energy information. Let's see. Try to think. Comes up. This is a report I'm actually working on right now that's due next week, so it's kind of a rough draft, but just to share a few quick numbers. One of the things that we do in Energy Management, we have a fund that's specifically for energy savings projects, and then this is kind of where we, like with that football field project, that's what we use as this energy management fund. And you can see right here, this is a breakdown over the last 7 fiscal years of the money that's come into that program. So we're using somewhere in the neighborhood of $500,000 to $600,000 per year that's coming into the fund. And you can see of that, that's the chunk that comes from incentives and energy savings each year. So, like for example, just this our fiscal years run July to June, so this is just the end of last year. We had $230,000 in university funding into the fund, $109 in energy savings, and $165 in incentives, and a little bit of others, so about $500,000 in the fund. And just kind of turning down. Here's the amount of energy we've been able to save. Fund to date, this is cumulative. From projects we've done through the fund, we've saved about 35 million kilowatt hours. Seen an average demand reduction of about 1.6 megawatts, and saved about 109,000 decatherms in natural gas over those last 7 years.
You're going to hear the term low-hanging fruit.
Yeah.
You'll notice how those numbers start out real high, and those projects, the easy projects, were done quickly.
Yeah.
And now it's tougher to find the projects, and some of those projects become more expensive to do, and so we're actually going back and looking at projects that we had passed on before and taking a second look at them and see if there's a way that we can make them work.
Yeah, exactly. And to speak to that, cost savings is just a fiscal year breakdown of cost savings. Let's go through that real quick. But this table right here is not put together entirely yet. That's why this yellow number, highlighted yellow, doesn't have all the data into it. But you can see the simple payback for projects over the years. And that's really not going to be 28.2 for last year, but it's probably going to be similar to being around 7 or 8. Like Bill was saying, go from 3.1, kind of getting up to 4, 4.5. Now we're going to be up over 5. So yeah, the low-hanging fruit is going away. We're kind of getting longer payback projects and everything. So yeah, just some stuff here. And then in terms of energy usage, let me open up my little file here real quick. Go back a year. I don't have this last one done yet. So we'll go back to this one. This is from a year ago. And here's our energy usage. So if you look, this is 5 different years overlaid on one chart. But that's kind of the profile of energy usage. So we're looking somewhere in the range of 25 to 30 million kilowatt hours per month in the summer, down to somewhere in the 15 to 20 million kilowatt hours per month in the winter for electricity usage. Gas, this is in decatherms, from 100,000 decatherms up to over 300,000 in the winter per month.
It's going up.
Well, yeah, exactly. I mean, FY13 peaking right there, and you go back here. FY13 is actually down, looking pretty good. So we're making more progress in terms of electricity than I think we are in terms of natural gas and energy savings. There's the total energy savings, or the total energy, sorry, not savings. But FY13 is kind of tracking somewhere near the top, and even though our EUI is going down, our total usage is going up, and that's because we keep building, and it's more energy. So in terms of cost, electricity costs, we're looking at anywhere from the summer close to $2 million a month, in the winter about $800,000 per month. And cost is almost always going to just stack right on up, because rates go up every year. And gas cost. Gas has been a lot more variable over the last few years. 6-7 years ago, it was double what it is now. It's really come down. But it's starting to, it kind of hit the peak, or not the peak, but the low, the valley a couple of years ago, and it's kind of steadily creeping back up. But natural gas costs are a little more variable than power and electricity, and so than the total energy cost. And then the next set of graphs are looking at, total energy cost. This is not including water, all utilities, just natural gas and power, electric power. We're looking somewhere between $2 million and up to $3 million per month in costs, or our total spend is about $25 million per year. And then here's rates. Up. 9, 10, 11, 12, 13. And gas rates, 9 is up here. There's 11, 13 down here. So we're starting to see some change. And then, so here's our total. This was for fiscal year 13. So this report's a year old. But our total cost $25 million for that fiscal year.
So when did you start doing the energy kind of things and calculations, energy savings and stuff like that? Have you always been doing it, or just recently in the last few years?
So, the university, we really became, invested in energy efficiency in about 1998. We the university hired Byron Energy Services to come in and do, what do you call it, ESCO project, either ESCO or Energy Savings Performance Contract, ESPC.
Can you explain that just
Yeah.
a tiny bit?
So what that is there's companies out there. Chevron Energy Solutions is a big one. Johnson Controls has one. A lot of the major manufacturers like Train and have arms of their companies that'll come in and will do an audit and determine what kind of projects can be done to save energy, and then they'll help pull you to the financing to do the project, and the whole thing is paid for from the energy savings. And so the company, it's almost like a turnkey situation where they'll come in and help, whatever. I think most people who participate in these kind of projects are government or institutions, a lot of colleges. The federal government does a lot of them, military. And so you just basically hire the ESCO to come in and they do all the work. They do the audit. They guarantee the savings, which is a big draw. So that way, if they're saying you're going to save $2 million a year and you've financed it and you're depending on that $2 million in energy savings to pay for the project, they'll guarantee it. So if they don't hit it, they'll come in and do whatever it takes to get things right to hit those numbers. So that's kind of an ESCO project in a quick description. But anyways, we had Byron Energy Services, which later became Chevron, come in and we did 5 phases of projects here between 1998 and 2001. And so that was kind of the first real, step into energy efficiency. And energy management as a group was born on the tail end of those projects, because as those projects came to a close, the university saw the need to have a group focusing on energy efficiency going forward to kind of help maintain the savings and make sure that things stayed in line, and to ensure that those savings would continue. We're still paying those projects back. The bonds still exist, and we're still paying on them. And so every month we do what's called an M&V report, measurement and verification, where we have a third-party contractor come in and look at all the energy bills and do an analysis to say, yeah, here's where you are relative to the baseline, and here's how much money you saved this month. And we don't have a guarantee anymore with the project, but we are tracking it to make sure that energy savings are covering the debt service and the financing. But that's really kind of that's how energy management came into being here at the university. And it's kind of grown since then. It started out really just as a group that did little projects, read the meters, took care of a little bit of the data, and now we're much more plugged into what's going on around here in a lot of different ways. So, yeah. So anyway, so just a real quick kind of overview snapshot of things we're looking at. So I'm gonna close this down and go look at some cool stuff. Yeah, it's the first time we did it, we talked.
then you've got this waste heat recovery unit. As you see, I was a little low there. It's coming in at 900 degrees. So, and let's see, the furnace temp's only 650. So, but this is generated just like this. You're using that hot air, trying to use as much of that power, that energy that you get out of having to spin that turbine, and burn that gas. Take out as much of that energy and use it to heat up this water. Now, if you saw, he was showing you on the one side, the burners on the one side, see, this is only showing that there's only just the one burner running right now. Anyway, there's a row of three, a tier of 3 burners in there. But without these burners here, you can produce about 22 million BTUs. Okay, and so when you put this into the factory, you're up around 100 million. So when we get, like it says here, this is calculated efficiency. We're around 75%, which doesn't sound real good, and it's actually it is a little off. So the solar guys will probably be out within the next month or so, and I'll be doing some stuff on the turbine itself. What's the maintenance they do on stuff? So how much maintenance is on? Well, every 5,000 hours, they pull the turbine, and you do a brand new turbine stuff in there. So that's one thing. But every 6 months, they come in and we go down for a day, and they try to go through everything. And if we've got some problems, like, I don't know whether you guys noticed, there's a little oil leak in there, and that's, well, yeah, it's a small one. I mean, we've had worse ones, but they'll come in and they'll check all seals and things like that. You know, what for a turbine, oil is number one thing. I mean, you got to keep it clean and you've got to keep it cool, because you're running at such a high heat on those things. You're running around 1,400 degrees in certain sections of the turbine, and so you've got to keep those bearings cool, so in order for that thing to spin. But they come out about every 6 months, like I say, and go through it. I think they're scheduled in October to come out. And but yeah, it usually runs around about 82% efficient, and that's about as good as we can get out of it. When you start looking at other things, I mean, it's pretty good.
You mentioned out there it was kind of loud, Bill. That it gets off a byproduct of electricity.
Well, the idea is, I mean, primarily what that cogen unit was there for was to make the high temperature water.
See, this is what we call a heating plant. This produces for the whole lower campus. And what I mean by lower campus, you go up to Mario Capecchi Drive, all the way down. Everything that's down here, we produce the heat for. Okay, there are a few places that have some individual boilers in them and stuff, but that's really rare. I mean, we produce all the heat for the lower campus. There's a system of pipes that go through underground through every building, and that's how we supply the water to different heat exchangers that are in each building to give you that heat. So you send water down there at 400 degrees and 350 psi, and it comes back up here around 260 degrees or so, and so it works pretty efficient. They've recently upgraded the systems around here to where we've got like a triple wall self-insulated pipe instead of, we used to be a single pipe that went out, and you would insulate it in what they call gill slate. It's kind of like if you cracked open drywall, the white chalk and shit that's inside the drywall. But you would cover that to a certain extent all the way around it, about what was it? I think it's 2.5 feet in each direction. So you had to you figure all the piping that you got through this whole place, you know, you got to have that all covered with this gill slate. And so it's a lot of that. Just that in itself. You know, if you ever have a leak or anything like that, you dig it up. This triple wall self-insulates, keeps more of the heat in the line, and there's also a system that goes through it. I guess we didn't opt for that option. I don't know. It's supposed to alert you to leaks in different areas, you know. But that's already in the line. All we got to do is, I guess, hook it up. But this is the most efficient way, I guess, to do this. I come from a power company background, so I worked for 25 years for Utah Power before I retired and came here. And this is a lot different. But this is like what you're talking about. This generator out here is being a byproduct. Yeah, in a sense it is a byproduct, but it's also what we're looking at is the byproduct of that generator itself is what's heating our water.
And that's kind of the interesting thing. My voice is going. But the terminology is all kind of around power production because they call it a waste heat recovery unit. But for us, it's essentially just a heat exchanger that's allowing the water to capture the heat. So for us, it's not waste heat. It's almost like waste electricity. That's the byproduct. But in most applications, it's the opposite. You're producing power primarily, and the heat is then collected for whatever.
They've got several different systems that they could have gone with. I mean, actually, these old boilers, if they would have been more structurally sound, they could have come in and gone into one of the walls and actually put the turbine blowing into there instead of this whole thing. Because that's all that waste heat recovery unit is another one of these big generators. That's what they call them, is a water generator. But that's what you got. Anything else? Any other
That's
questions?
pretty good, yeah. I think we'll head off to the north plant while we have some daylight.
Yeah.
Check that out. That's the tank itself. So the whole concept behind the plant, the reason we did it is, so I don't know if you're aware of this, but Rocky Mountain Power has, it's basically time of day usage. They have on-peak and off-peak hours. And so on-peak, both the energy and the demand both cost more. And so there's an advantage to running heavy equipment at night when rates are cheaper. And so the whole idea is the chillers in that building can chill the water in the tank during off-peak hours when electricity costs less. And then that water can be distributed to the buildings it feeds. It feeds about 13 buildings, I think, between, UStar, which is the building behind it. That's a new engineering science building. It feeds all the way down to these buildings along here, Alumni House, the Humanities Building, engineering, which is over across the street, feeds this kind of district, chilling water. So, unlike the other plant where I was showing you where they took all the chillers and they put them all in, and they're basically using a lot of the same chillers, but just in one plant. This one, they just put in big new chillers because it's a different operational strategy. Here, we're not trying to necessarily stage and modulate like there. Here, we're trying to just make chill water at night. So the idea is they run them straight out, all out flat, until that water is to the temperature it needs to be, and then turn them off. So.
Do you just cringe when you build something like UStar, which is apparently an energy hog?
Well, yeah, as an energy manager, yeah, you do kind of cringe because you're trying to go one direction, and then you put one of those up, and it's instantly a giant black hole for energy. It just sucks it in, and it's gone. That's part of the mission of the university is research and economic development, which is why that building was built. And And so we support it and you try to do it as efficiently as you can. So this building was built so that it will eventually house 4 of these. And it's meant to grow as more buildings come along the line. Who knows how long it is. All these parts and pieces right there is just storage. On the far left is a chiller that pulled out of Merrill Engineering when they put this system online. I think that's small. I'm not the one that's small came out of an engineering building also. But yeah. Like I said, I'm very happy to really see these things offer. Around, I can't remember exactly, but like 8 a.m. to about 7 p.m. So during the winter, the on-peak hours are actually longer than they are during the summer. And that's largely done by the power company to both penalize companies who use excessive power in the on-peak summer hours to encourage money and to encourage less usage during those hours. So, yeah, I mean, in here, what's that? Yeah, it's one interesting concept of energy management. There really isn't anything in this room that I can show you where you can say, this is energy efficient, this is saving energy. This plant's really designed around saving cost. But let me ask you a question. If you have a piece of equipment, when is that piece of equipment using the least amount of energy? When it's off. So really, energy management, I mean, all the stuff I showed you in that plant, the stuff here, it's all just equipment. You turn it on, it's going to run, it's going to burn energy. So really what energy management is about is understanding how, through data, to control the equipment. To know when it can be off, when it can be ramped down, when it can, turn it down. That's really what, if you're doing energy management, that's the goal and that's really what you're trying to do. So really learning about all this stuff just kind of gives you the understanding of how this stuff works, so then you can understand what kind of strategies you can employ to reduce the runtime on this type of equipment. So yeah, let's go on outside.
As we add to it now?
Yeah. So add more plates, you get more capacity. Here's the tank. I'm not sure how far down to the ground it goes, but this goes down into the ground too as well. But I think it's just a big concrete tank, big reservoir. Either by the chillers or by the cooling towers, the water gets chilled and pumped into there. About 3 million gallons.
I think I was told that there's actually more of this below ground than you see above ground. So.
Yeah, it's just basically a big giant concrete structure that's filled with water. So. And of course, with that much water, you're going to get stratification of temperatures. You're going to have colder water at the bottom and warmer at the top. So they pull the water off the bottom and distribute it, and then return it to the top, and then they keep it cycling through that way.
Do you manage like water usage at all?
We don't actively manage it just because what little money we have goes into energy. Although it's something we're very conscious of because it's going to become more and more of an issue.
Yeah, kind of directly related.
Yeah, well, they are. I mean, it's a utility cost and it's a rare, precious commodity.
Yeah.
Water. Plentiful, like our rates seem to imply.
Yeah.
So, anyway, this is a cooling tower. It's in operation. You have water just falling down in the air. The whole idea is that it's basically a big fan. And so the water comes in and they spray the water into the airstream, and then as the water evaporates, it cools. And so the water that doesn't get evaporated becomes colder and it falls to the bottom. It just drops down from where it's sprayed through. And then, in fact, you can see the power water supply, those are the pipes that deliver the water into the utility tower. Sprays it in, air comes through, cools it, it drops down, and then it actually gets sump underneath where the water goes, and then if it's operating the chillers, it interacts with the chillers, or it can interact with that plate and frame heat exchanger in there to provide that cold water directly to the end. That's kind of a simplified version of how it works. It's a very simple process, actually. What's that? Yeah.
One of the things we talked about, scheduled shutdowns, one of the things you don't want to have happen is an unscheduled shutdown to the cogen, because it will produce a big spike in our electricity usage, because if we quit making our own electricity, the power company has to make up the difference. And when this thing first came on, we had some unscheduled shutdowns, and it was hitting us, and it was something like $15,000 to $20,000 a month just for it to shut down for 15 minutes. Because it would recite the way they bill you demand. So you really want to schedule the shutdown in a way so that you're not going to create a spike in demand for the university. And so the maintenance is really critical, because
So it's going to help a lot more on that than the other cooler boilers?
I don't think, I think because you got the spinning turbine, I think, you've got to really make sure that everything is going correctly.
I mean, when it's running like it should be able to run long hours flawlessly. But the maintenance that's required. I mean, with a boiler, you don't have to go in and overhaul it, twice a year. But like you were saying, you have to replace that turbine every 5,000 hours. That thing runs a lot, so I imagine it's at least once a year.
Yeah, I was going to say, I was just trying to figure if you're running how many hours in the year.
Yeah.
It's probably about a yearly.
So this plan is kind of related to that concept in the same way. I mean, here we're trying to run this during off-peak hours. The cogen plant, we don't, going to run it during peak hours. So, for the same concept, just avoiding that additional cost. So, but yeah, I mean, the same thing. If this plant comes on for whatever reason during peak hours, you kind of just destroy the whole reason why you built it. So the operation becomes really critical, and how we maintain it, how we keep it running during the scheduled, some kind of